Hello. In this video, I just want to extend on some of the concepts we looked at previously. So we're going to keep graphing exponentials, but we're going to add some more transformations. So here we have y equals negative 3 times 2x plus 1. So what is this going to do to our exponential? Well, let's go back, make a table of values just like normal. We'll try negative 1, 0, and 1. Because it doesn't look like the graph has been moved left or right. And let's see what we get. Negative 3 times 2 to the negative 1 plus 1. That'll be negative 3 times 1 over 2 plus 1. So negative 3 over 2 plus 1, negative a half. Okay, for 0, this is negative 3 times 2 to the 0 plus 1. That's a little easier. 2 to the 0 is 1, so we just get negative 3 plus 1, negative 2. Okay, here, negative 3 times 2 to the 1 plus 1, so negative 6 plus 1, negative 5. All right, so if we go ahead and make a table of values here, or a little xy axis, what do we got? 1, 2, 3, 4, 5. So at 1, we've got negative 5. At 0, we've got negative 2. And at negative 1, we have negative a half. Now, because of that plus 1, we know the horizontal asymptote will be at y equals 1. So we should throw that on our graph just to help give that guideline. And then if we connect the dots, well, we should be good to go. We have our basic exponential shape. Now, obviously, this exponential shape is a little different. Normally, it goes up like this, and this time it goes down. That's because it's been reflected, right? This negative 3 means a vertical reflection, so that's why the graph looks the way it does. But we don't need to know about the reflection. As long as we make our table of values and grab our y asymptote, or our horizontal asymptote, or our y asymptote, we should be good to go. I always recommend, again, 3 points. You might be able to get away with 2, but I think 3 points is really safe. So let's go ahead and try another one. Here we have y equals negative 1/2 times 2 to the x plus 1 plus 3. So pause the video and see if you can give this graph a sketch. Okay. Well, the plus 3 will be that horizontal asymptote at y equals 3. So that's pretty good. I think because of this plus 1, I think that means we've moved the x values left 1. So I'm going to move everything to the left. So I'm going to do negative 2, negative 1, and 0. Kind of making the whole table kind of move left by 1. And then let's try with that middle one again. I think that might be easier. So negative 1/2 times 2 to the negative 1 plus 1 plus 3. Well, negative 1 plus 1 in that exponent will be 0. So we have negative 1/2 times 2 to the 0 plus 3. 2 to the 0 is 1. So this is negative a half plus 3. So that will be 5/2. All right, let's try here. Negative a half times 2 to the 1 plus 3. So that's negative 2 over 2 plus 3. Negative 1 plus 3, or 2. And here we've got negative a half. Oh, this is going to look nasty. You know what? I think I might do 1. So negative a half times 2 to the 1 plus 1 plus 3. Yeah, let's skip this point here. Negative 1/2 times 2 to the 2 plus 3. So negative 4 over 2 plus 3. Negative 2 plus 3, which is 1. You got to be a little flexible when you're doing a table because you're looking for nice numbers. You don't want horrible numbers. So we've got negative 1, 0, and 1. And we go 1, 2, 3. Okay, so at 1 and 1, 0 and 2, negative 1 and 5/2. Don't forget about that horizontal asymptote at y equals 3. And again, we connect the dots. And we're good to go. There's our beautiful exponential graph. Again, with a table of values and that horizontal asymptote, you should be good to go. All right, one more here. We've got 4 times 1/2 to the negative x plus 2 minus 1. So here we've really got like so many transformations going on. Do your best to give it a sketch. All right, so this is our horizontal asymptote at y equals -2. And then it's time for a table. Well, there's a negative x plus 2. I don't know. I mean, we could try -2, -1, 0, 1, 2. If we make enough points, surely we'll hit something nice. So let's just look there, right? We're going to try to inspect and see which x values might work out nicely, because we don't want horrible numbers here. Let's try the 2, because -2 plus 2, that should be nice, because that'll be 0. So this is 1/2 to the 0. Anything to the 0 is 1. 4 times 1 is 4. Okay, 4 minus 2 is 2. That point worked out all right. Let's try the next one here. 4 times 1/2 to the 1, because -1 plus 2. Okay. I guess that's 4 times 1/2. 1/2 of 4 is 2, so 2 minus 2 is 0. Okay, that's not too bad. Not too bad. One more here. 4 times 1/2 to the 2. So 1/2 squared is 1/4. 1/4 of 4 is 1. -1. Okay, so we were able to come up with some nice points. That's good. Let's go ahead and sketch them. Remember, we do have that horizontal asymptote down at y equals -2. Okay, we got 0, 1, 2. And we got, so 2 and 2. 1 and 0. 0 and -1. Connect the dots. And bingo, we're good to go. What's kind of interesting about this one is it was 4 times 1/2 negative x plus 2 minus 2. So you might have been looking at this and thinking, oh, exponential decay. So you were thinking the graph would look like this. But then it looked like exponential growth. But that's because the negative here actually takes that exponential decay and it does a reflection across the y-axis. So we reflected it. And if we reflect it across that y-axis, we can see it transforms the exponential decay back into exponential growth. Now, you don't need to know that. This is just extra over here. But that's why the graph looks the way it does. So, kind of interesting. But again, if you use a table, y-axis, it's really all you need and you should be good to go. Now, for notes here again, this is pretty much the same as before. There's not really anything new. So I would just recommend that you try again Unit 8, Worksheet 6. Just keep trying these questions. Make sure you're able to work on the arithmetic. Make sure you're able to make the tables. Many of these questions would be no calculator. So if you're having trouble with adding the fractions or doing the exponents, just work on them until you feel comfortable, because these would be the kind of sketches that you'd have to make a table for, but you would be a no calculator table. All right, hopefully you enjoyed this video, and as always, thanks for watching.